Hello and welcome Math A212 students. We're going to be looking at section 10.1 today. So let's get started with congruence transformations. Your Common Core standards for congruence transformations include the 4th grade on through to the 8th grade, with topics beginning in the 4th grade where you're folding figures into matching parts over a line of symmetry. Then in the 8th grade we're going to be looking at congruence and transforming shapes. So these are the different topics that we'll be looking at today. For a transformation, if you'll take some sort of object such as a book, put it in front of you, and move the objects in different ways so that it's still on the table, meaning it's still on the plane, this is going to describe a transformation. So we're looking at two-dimensional transformations is what that's trying to say to you. So we can't move it higher or lower on a z-axis in the plane, just in an xy plane. We can look at this letter P and notice how we have transformed the letter P in different ways. They ask you to write down how you might describe this. Let's just look at what they tell me each one is. For transformation number 1, you'll notice that it's just basically a slide. We're going to be calling that a translation, but anytime you hear the word translation, just think of it as a slide. Notice how I slid the P around. In transformation number 2, I have flipped it, meaning that I have reflected about some line. So let's get my pen. So in this, you'll notice the line of reflection here would be that line right there. So I've just taken that P and flipped it. If this was on a piece of paper and I folded that piece of paper, that's how I made that. It's going to be called a reflection, and that's how I'm going to refer to it from now on. In transformation number 3, I have rotated it about some point. So that point looks like, let's see, it looks like it's going around this circle here. So the center, you have to kind of find the center of that. Looks like if I were to take that P maybe from about here and rotated it around, that would be a rotation. Finally, in transformation number 4, we have shrunk that P down, and in number 5 doesn't really look like much of a P at all, but it is kind of a squiggly, we have distorted that P. When I look at the word translation, we typically think about going from one language to another, but in geometry it just means moving an object along a straight line and not turning it. That is a translation. So let's look at this object right here. If you'll look at that object as those two pieces, I have moved those two pieces along that straight line. Now you could look at an individual piece, in which case that's going to involve something that's a little trickier. But as far as a translation goes, I could take this chunk right here and move it along this straight line, and I would say that's a translation. Another example of a translation would be if you do some paper cutting, make paper dolls, and it's just that same shape that is slid along, and we have the same figure. So in this, they want you to imagine taking some triangle and translating it using scissors, ruler, and it's just kind of a fun little exercise to look at translations. You might think about using that in one of your videos. When we talk about a figure and its image, that's what we're talking about. We're talking about the figure, and then we do the translation, and that's his image. So let's look at some properties. Here's a triangle that has been slid along this line here, and you'll notice that everything about it is the same. I have parallel lines. Nothing has really been tweaked. Here's them talking about this again. They're wanting me to translate that rectangle and move it about that line, so that means I'm going to draw a rectangle down in here somewhere, and here is that answer to them doing that translation. Here is a reflection about a line, if you just imagine it on a piece of paper and folded that piece of paper, pretend like it was like wet ink or wet paint or something, and then you fold it about that line, what would be the image that you got on the other side? That's a reflection. Once again, they're wanting you to imagine it as a piece of paper and folding it. I think we've already said that. Oh, that line of reflection, let's go ahead and define the line of reflection. You can find that line of a reflection if it is indeed reflected. So look for that. For a rotation, you're going to look for a center point. You're going to look for a fixed center point about which our object is being transformed to its next image. So here is an example of that. Finding that center fixed point and then taking each point and rotating it about that point. So in summary, I found a cute little drawing where we had a translation, a reflection, and a rotation. So look for those things whenever you're looking for those different congruence transformations. So let's look at this example. I'm looking at this one. It appears that this is a reflection because if I folded that piece of paper, there he would be there. I think this is a rotation, and here's the center, and it was just rotated about that center point. Let's see, this C. C just looks like it slid about this line here. D. I think it's not, I can't find a line here for a reflection because it wouldn't be, I think it's just kind of spun about maybe this point here and then you just rotated it around. I think that's how you would get from one point to the other. This one I think is a reflection, and that being the line. Notice if I folded the piece of paper, it'd be the same on either side. This guy, it wouldn't be the same if I folded it across. So I think, no, it would. It would be. Let's see. If I folded that, because it's not going to be rotation because it wouldn't be that same picture. It's not a slide because it's not just up or down. I think it might be, let's see, if I folded it about right in there, would I get that same, well, maybe not there. It would have to be like this. It's about finding that line. I think it might be a reflection about some line around in there, now that I look at it. A composite transformation is one where you have several things happening at once. These are a little harder, so let's look at these. In this one, I have moved the flag from position 1 to position 2, and then I have reflected it to get to 3. So this is a translation, then a reflection. I think you have some homework questions where you're going to be answering things like that. Translation vector does not need to be horizontal. Now it can be in any direction, so I can slide it in any direction. So I can make it angle. However, in order for it to be a glide reflection, that whatever direction your translation vector is in, the reflection line must be in that same direction. So it's always nice to look at something that doesn't obey that. If you'll notice this particular flag, he's not, because he did not slide in this direction, and that's how he would have had to have slid in order to get a glide translation. A nice glide translation or glide reflection is, this would be glide reflection because there's my line of reflection. So here we go, and the footprint being reflected on either side. This is summarizing some different things that utilize transformations of different sorts. So there's your summary. And now that we know we can move any figure to any position through a combination of transformations, now we can talk about congruence. So we can say something is congruent if you can do some transformations and get that same figure back, or kind of move it around. You just slid it around the plane somehow. And a great little picture of some transformations and art. Escher did quite nice work in this. Alright, and that's all we have for section 10.1. I hope you've enjoyed it. And if you have any questions, be sure and shoot me an email. Thank you guys. Have a great day.